This is an excerpt of a conversation between J. Craig Venter and Emil Jacobs, brought to you by the Chemical Heritage Foundation's annual T.T. Chow Symposium.
So I want to start it off by directing the question to Emil about why ExxonMobil, not known for being really prominent or even doing anything in this area, because I had a very successful business in the fossil fuel area. Why did you get interested in biofuels, and why algae as opposed to other ways that you might think about biofuels?
All right, let's go back about 4 or 5 years ago, and the corporation had the question of, should we be doing something in the biofuel space? And it was a question that we didn't have a good answer to. So the way we normally approach a problem like that is pull together a team of some high-level folk and say, figure out what we know about biofuels, and is there anything that we ought to be doing there? So we pulled together this high-level team and said, go look at every biofuel option, figure out what was known about them, what the prospects are for them, and come back with all that information. We'll figure out what we want to do in that space. And with all of that work done, we looked at the options along several dimensions. The first one was scale. If the option could not scale to the point where it could be a meaningful contributor to U.S. transportation fuel supply or global energy supply, then we weren't interested in it. So there may be small applications or niche technologies, but if it doesn't scale, ExxonMobil's not going to be interested in it. So scale was the first criteria. Second one was a technology assessment. What's known about the technology? How mature is the technology? What are the prospects for improving the technology? And kind of how we thought that might play out, and what did we bring to the problem? Did we have capabilities that would impact that? The third criteria was environmental footprint. So what was the CO2 footprint, the freshwater footprint, the land footprint? And if those were positive, then it stayed on the list. If they weren't, then it got culled. Fourth criteria was economics. Could we see a path from where the technology was today to get to the point where the cost could be low enough to where it could actually compete against traditional energy options or transportation fuel options? And the last criteria was our assessment of probability of success. Did we think we could go into this and be successful at making a commercial reality out of it? We used those criteria, looked at all the options. Some were clearly, we're not interested. The other group was, well, maybe. And we went away and did some more work there. And when you started looking at the options that were well maybes, algae biofuels kind of worked its way to the top based upon the criteria that I just described. The next question was, all right, we can't do this by ourselves, so who do we collaborate with to make this a commercial success? So clearly what we were looking for was the best, brightest biology option that we could find. So we looked at a bunch of universities, a bunch of companies, looked at national labs, and synthetic genomics rose to the top of that list. We then sat down and talked through, was this something that made sense, agreed on an alliance, and that's where we are today. So